Hi guys, we're going to do this problem, this circuits problem. They tell us to use the circuit below to solve this problem, so we're gonna use it, of course. Find the steady state value of BZ of t. So we have a circuit that is in time domain, right? It's in time domain. And we know that there is an easy way to solve this. That is called Phasor domain. Right? So to convert this circuit to Phasor domain, we need to convert this capacitor, this inductor. And whenever we convert this circuit to Phasor domain, we can treat this inductor, this capacitor as a resistor. That's why we do that. And then we're gonna find BC of M in my Phasor domain. We're gonna find this, and we're gonna convert back to time domain so we can get the answer. So let's do that. So to do that, we know that the capacitors convert to Phasor domain as impedance, which is 1 over JWC. And this is gonna be in ohms. And we know that the inductors are gonna convert by doing JWL. And this is also going to be in ohms. We can also convert these two. We know that this is the voltage and the current as a function of time. And we can convert this to Phasor domain by doing BS1M equal to the magnitude, which is this, 24, and the angle, negative 52. Same thing for this, IS1M equals to 87, and the angle is 137. And just remember that this is milliamps. This is volts. Perfect. So we can start drawing our circuit. What we're gonna do is redraw everything. And you probably have to do this when you're taking an exam, so it's easier for you. We have an inductor, a resistor, current source, and finally we have this voltage source. Perfect. So now we're gonna start by putting values into our new circuit. This is our new circuit in Phasor domain, and we already know that this right here is gonna be, so this one is my BS1, so BS1M is going to be equal to 24, angle negative 52. This is going to be, this one right here is going to be 87, angle 137 milliamps. Forget about that. We know the resistors are the same. They don't change. 300, 350, 220. And 1 kilo ohm. And this also converts millisiemens, and the other thing that converts is BCM, right? Now for the inductor and the capacitors, we need to convert by doing this. So the impedance of this capacitor, let's call it C, impedance of capacitor 1 is equal to 1 over J W. We know that W is this, whatever we multiply T, right? So by looking at this, we know that W is 15,000. Also, we know that this, the W for this one is the same as the W for this one, right? That's how you know that you don't have to do superposition. If this were different, then you will do superposition. Okay? Here, we don't have to. So this will be for impedance of C1. This is my C1. This right here. And this is going to be my C2. So impedance of that is 1 over J W, which is 15,000 times 0.2 times 10 to the minus 6. So I'm gonna put that in my calculator. And when I do that, I get negative 333.3 J. And this is in ohms. Now for my impedance of C2, it's going to be basically the same thing. J times omega, which is 15,000 times 0.3 times 10 to the minus 6. And this is going to be equal to negative 222.2 J ohms. Okay, so now we have for this one negative 333.3 J, and this one will be negative 222.2 J. Now we need the L, we need the inductor, right? I'm gonna move this so we can have like a little bit more space. So for the inductor, which is CL1, we know that we have to use this. So CL1 will be J times omega, which is 15,000 times L. L is 22 millihenry. So 22 times 10 to the minus 3. And when you do that, you get 330 J ohms. Perfect. So now we have everything we need. This is 330 J. We have everything we need. We can treat the capacitor and inductors as resistors, and we can solve the problem. We also know that BC of T, because that's what we want to find, BC of T is across these two capacitors. So don't forget to put that. BCM is across these two capacitors. And this BCM is not BC of T, because we changed everything to Phasor domain. So you can do whatever analysis you want. You want to do KVL, KCL, mesh. But I'm gonna do NBM, no voltage method. And to do that, I'm gonna color my nodes. I'm gonna color this node right here, and I'm gonna make that my ground. Also for the other ones, I need to find my essential nodes, and I have to have more than three or more. It can be capacitors, inductors, resistances, or sources, in order to qualify as a essential node. So we're gonna use this to mark. Okay, so I know that this one is an essential node because it has 1, 2, 3, 4, 5, more than 3, right? 3 or more. That's the rule. And I know that this one also has more than 3 resistor, inductors, capacitors. Well, inductors, resistor, so 3. Perfect. This one only have a resistor and a voltage source, so it doesn't qualify as a essential node. So this is all we need for our MBM. And now we need to define our voltages, right? So we know that this is our ground, so every essential node needs to be in respect to the ground. So we know that this right here should be B1, right? And we can put a plus, and we know that the minus will be here. But we already have that. This is our plus, B1 minus. So it's already defined. We don't have to define anything. For this one, we don't have anything here, right? So we know that this is B, we can call it B1 instead. If we call it B1, the plus will be here and the minus will be here. So it will be B1M. So let's do that. Plus, minus, B1M. Perfect. So now we have our two nodes defined, and we can do the KCL, the no voltage method basically. So let's start with BCM, and let's do this part right here. So BCM minus B1M over this. BCM minus B1M over 338 plus BCM, let me see, yes, perfect. Okay, so we did this right here. Now we're gonna do this. So BCM minus 0 over the total resistance, right? And that's 650. So BCM over 650 plus, what else do we have in this node? We have this. So we did this, we did this. Now we need to do this, and this. So BCM minus 0 over the total resistance or impedance, right? So BCM over the total impedance, which is 555.5 negative J, right? Now we're going to do this one plus BCM over 470. And then we know that the last one is a current going in, and we define that whenever it goes in, it's negative. So minus 87, angle of 137, and we know that this is in milliamps. Don't forget. What it basically means, you multiply this by 10 to the minus 3. So you can let the calculator do that. So now for the second equation, we know that the other node, essential node, is B1M. So we're going to do the equation for B1M. So let's do B1M minus BCM over this, right? So we're starting with this part of the current going out of that node. So B1M minus BCM over 330J plus, what else do we have here? We have a current going out, right? So this one is a current going out, which is already defined here. So we don't have to do anything here. We already have a current. Because going out then is plus 15 millisiemens times BCM, right? What else do we have here? We have this, a current going out here. And to do this, we know that there's a voltage source here. So we have to do B1M minus 0. Then we go back the first thing we encounter is a minus. So minus this over the resistance. That's how I do it. I just follow a simple rule, and it's super easy to remember. So this minus this, I go back. The first thing I encounter is negative this over 220. So plus B1M minus 0 minus 24 angle of negative 52 over the resistance, which is 220. And this is equal to 0. So once you have the two equations, we know that we can just put it in a calculator and get the answer, right? So we're just gonna do that. Move this a little bit up. And when you do that, you should get something close to these answers. BAM equal to 25.5 angle of 29.7 volts. And a BCM B1M. So BCM should be 6.85 angle of negative 144.6. And this is volt. So now, what is the question asking? It has to find the steady state value of Vc of t, right? We did all this information to make the circuit super simple to solve and to find what's BCM. We found what's BCM is this. So now we just convert back to time domain and we should have the answer, right? So to find the answer, we just have to do BC of t magnitude, right? And the magnitude is what? 6.85. And we know that this is volts. Then times cosine of omega t. But we know that omega is 15,000 t times t minus the angle. And we know that the angle is this. So we do minus the angle because this is negative. If it's positive, it's a plus. But because it's negative, we find a negative, it's a negative. And this is how we convert to time domain. And this is the answer. So again, what do? We convert this circuit into Phasor domain to make it super simple to solve and find BC of n. Once we found what's BCM, you get the answer, you convert to time domain, which is super simple, magnitude and angle, and you already had the W. Once you do that, you convert, you have BC as a function of time. And they were asking for BC as a function of time. So that's basically everything. That's all for this problem.